If your heart stops for 1 minute, your story doesn't necessarily stop with it. In hospitals around the world, people are pronounced clinically dead, and then come back describing the same strange landmarks: a tunnel, a light, a presence, a life unspooling in seconds, a view from above their own body. The question isn't, are they lying? The question is more unsettling. Why do so many minds, at the edge of shutdown, draw the same map? Picture the room with me. A bedside monitor throws a pale green glow across the sheets. The air is too dry. There's the soft plastic smell of tubing and disinfectant. Someone's hand is wrapped around someone else's hand, not tightly, because they're trying not to hurt, but firmly, because the body understands what language can't say. The rhythm on the screen stutters, then slows. Each beat feels heavier than the last, like time itself has gained mass. And in that thickened time, the most human question rises up. When the brain is running out of oxygen, what happens to the experiencer? Does you fade smoothly, like a dimmer switch sliding down? Does it fragment into scattered sensations? Or this is the one that refuses to leave us alone. Does experience sometimes intensify right when the machinery is failing? People report peace. People report terror. People report clarity so sharp it feels more real than ordinary life. How does a mind produce a bright cinema in a theater that's losing power? I'm Rowan K. Mercer. On the Science Audit, we take extraordinary claims and treat them the way we treat any potential signal buried in noise, with respect, with skepticism, and with a refusal to settle for easy stories. Near-death experiences, NDEs, aren't one neat phenomenon. They're a cluster of motifs that repeat across cultures and decades. Tunnel and light, peace and presence, life review, out-of-body perception, crossing a boundary, returning with reluctance. Tonight we're not going to ridicule those motifs. And we're also not going to surrender to mysticism just because something feels profound. Instead, you and I are going to do something harder. We're going to build a model. We'll stress test it against physiology, oxygen, glucose, ion gradients, network coordination. We'll ask what the brain can do when it's cornered, what it cannot do, and where the data runs out before the mystery does. And if we're honest, we may leave with a conclusion that is both less comforting and more awe-inspiring than a simple, "It's all hallucination," or "It's proof of an afterlife." So step closer to the bedside. Not as a spectator, as a co-investigator. Because whatever the ultimate answer is, it's going to be written in the same place every human story is written, in the fragile, beautiful physics of living tissue. Start with the part we can say with confidence. Your neurons are not powered by will. They are powered by metabolism, the quiet bookkeeping of energy. Oxygen plus glucose goes into tiny cellular engines and becomes ADP. Think of ADP as the brain's spendable currency. Every perception, every memory, every sense of self is a budget decision. And the biggest recurring expense in that budget is not thinking. It's maintaining gradients. Here's the metaphor. Imagine every neuron as a coastal city protected by a seawall. On one side is the ocean of sodium ions, on the other is the city of potassium ions. The neuron spends ADP to keep those ions separated, like pumping water out of a boat that constantly wants to fill. That separation is tension, stored energy. When a neuron fires, it briefly opens gates in the seawall and lets the ocean rush in. That rushing is an electrical spike. But after every spike, the pumps have to work again to restore the barrier. If ADP is the currency, the ion pumps are the rent. Now take oxygen away. Not all at once, just a little less per minute. The heart falters. The lungs may still move, but blood carries less fuel. The brain doesn't panic in a human way. It triages in a physical way. It reallocates the last coins in the wallet. And this is where it gets personal. The functions you most associate with fine integration, sustained attention, careful reasoning, are not the cheapest features. They're expensive. They require many networks to coordinate across distance, like an orchestra keeping time without a conductor. As oxygen falls, those high-cost coordination tasks destabilize first. Simpler loops, habit circuits, reflex-like patterns, emotionally tagged associations, can persist longer because they're local, and local is cheaper than global. So if you've ever wondered why the edge of a crisis can feel dreamlike, or why time can warp during an accident, you've already met the first principle: consciousness isn't one thing. It's many processes bound together tightly enough that they feel like one. And tight binding costs energy. Now let's bring you into the brain's most underrated job: prediction. You don't experience raw reality. You experience the brain's best guess, updated by evidence. The cortex, your outer wrinkled layer, is less like a camera and more like a weather model. It runs forecasts. If I'm in this room, the next sound will come from that direction. If I move my hand, I'll see it shift. If I'm speaking, I'll hear my own voice with this timing. Then it compares those forecasts with incoming sensory data and corrects the errors. That correction signal, the mismatch between prediction and input, is the engine of learning and the anchor of reality testing. But under hypoxia, low oxygen, the correction signals degrade. Sensory input becomes noisy, delayed, or absent. And the brain, forced to keep the movie running, leans harder on priors. Priors is a technical word, so here's the human version. The brain falls back on the templates it already trusts: memories, cultural narratives, archetype-like patterns that have explained the world before. Not because it's mystical, because it's efficient. Ask yourself something that sounds simple but isn't: what is time? Not the ticking of a clock, time as you feel it. The sense that a moment has duration, that events have order, that now is sliding into next. In the brain, time is a coordination achievement. It's like a network protocol that keeps distributed systems synchronized. When coordination breaks, time can dilate, compress, loop, or disappear. That one sentence explains why people in car crashes report everything happening in slow motion. It explains why dreams can contain a long story even though the clock says minutes. It also gives us a foothold for NDEs. If the brain's timing and integration go unstable, the subjective timeline can detach from the clinical one. And that means you can't automatically map "it felt like 10 minutes" onto 10 minutes of normal brain function happened. Now, what does near-death research actually look like in the real world? It's messy, because death is not a controlled laboratory event. Most data are reports, what people remember after they return. Those are subjective. They can be honest and still be distorted. Then there are correlates, sometimes EEG readings, sometimes oxygen saturation trends, sometimes timestamps of cardiac arrest and resuscitation. Then there are constraints, anesthesia, medications, carbon dioxide levels, REM intrusion, sleep paralysis-like phenomena, expectation effects, cultural scripts. No single mechanism covers every case. If someone tries to sell you one universal explanation, whether it's purely spiritual or purely one neurotransmitter, that's a red flag. The honest approach is pattern audit: what repeats, what varies, what physiology predicts, what remains unexplained. So let's walk the motifs as if they're unfolding right now, in real time, from the inside. Not to sensationalize, to understand. First, the tunnel and the light. Imagine you're lying back, eyes open or closed, it might not matter. Your blood pressure is dropping. Oxygen delivery is falling. The first thing to degrade in many systems is the periphery. In vision, peripheral processing is often more vulnerable than the central field. Your visual world begins to vignette, like an old photograph darkening at the edges. The center remains, a surviving island of signal. Now add the brain's filling and function. Your visual system hates blanks. If part of the input disappears, the cortex doesn't shrug and display missing data. It paints over it. It uses context to complete the scene, the way your phone camera smooths noise in low light. Under stress and degraded input, that completion can become dramatic. A shrinking field with a bright center becomes a tunnel with a light. Here's a question you should hold in your mind. If millions of brains share the same architecture, and that architecture fails in similar ways under similar constraints, shouldn't we expect similar subjective artifacts? Just like people see the same optical illusions because we share the same visual wiring. Second, the peace. The presence. The feeling that someone is with you. This is where people's stories can feel like sacred text. And we have to be careful not to cheapen it, and careful not to let reverence substitute for explanation. When a body is dying, chemistry is not merely failing, it is changing states. Stress systems activate. Endorphins, your internal painkillers, can surge. Neurotransmitters that regulate wakefulness and dreaming can destabilize. Networks that usually inhibit each other can lose their boundaries. The result can be terror. But in many cases, paradoxically, the result can be serenity, dissociation from pain, a smoothing of fear, a sense of distance from the body. And the presence? Humans are social prediction machines. Your brain carries internal models of other minds. The way your mother would speak, the way your friend would judge you, the way a stranger might threaten you. In ordinary life, those models stay mostly in the background. Under isolation, darkness, and extreme stress, the social brain can externalize its models. That can feel like a companion, an ancestor, a guide, a figure made of warmth. Not because the person isn't real in experience. Because the machinery that distinguishes inner model from outer perception can blur when correction signals degrade. Third, the out-of-body experience. This one is almost cinematic. You're above the bed, looking down at your own chest, watching doctors move like choreography. It sounds impossible, so we either dismiss it outright or treat it as supernatural. But the brain has a specific place where am I? Gets computed. There's a region called the temporoparietal junction, the TPJ. Think of it as the stitching machine for body ownership. Every moment, it integrates signals, vision, balance, touch, muscle position, and the subtle internal sense of organs. It compiles those into a single felt coordinate. I am located here, behind these eyes, inside this skin. If that stitching fails, through stimulation, seizure, extreme stress, lack of oxygen, anesthesia oddities, the coordinate can decouple. The brain still needs a vantage point for its story, so it assigns one. And a stable vantage point is often above, because above is geometrically simple. You can see the body as an object, you can organize the scene, you can reduce chaos to a diagram. Ask yourself, if your brain's job is to keep a coherent narrative even as sensory inputs collapse, isn't floating above a kind of emergency simplification? A last-ditch way to keep the world legible when the usual first-person stream is failing? Fourth, the life review. People describe it as panoramic, instantaneous, morally saturated. Not just, I remembered my past, but I relived it, and I felt what others felt. We need to dethrone a common metaphor. Memory is not a library. A library implies books sitting intact on shelves. The brain doesn't store your life as finished books. It stores fragments, sensory traces, emotional tags, patterns of meaning, and rebuilds scenes on demand. Every time you remember, you reassemble. That's not a bug. That's how a living system stays adaptable. In crisis, the brain may batch process emotionally tagged memories. Why emotionally tagged? Because emotion is the brain's way of labeling what mattered for survival and social belonging. Under network instability, associations can fire in avalanches. One memory triggers 10 trigger 100. And because time coordination is breaking, the sequence can feel simultaneous, like all the pages of a book fanned open at once. Notice what this does. It creates meaning at the moment meaning is most threatened. If dying is the collapse of future plans, then the mind may pivot to the only place it can still find narrative, the past. It says, "Here is what your life was." Not as a spreadsheet. As a story with moral gravity. Now I want to stress test our model with a thought experiment. Imagine we could reduce oxygen to the brain in a controlled gradient, safely, ethically, with monitoring. Imagine we could watch what motifs emerge as integration fails in predictable stages. Would we see the same narrative landmarks appear across people, like similar failure modes in the same model of aircraft? Because that's what's so striking about NDEs, the clustering. Tunnels, lights, presences, reviews, boundaries, the recurring geometry of almost leaving. If you're an engineer, clustering suggests architecture. If you're a scientist, clustering suggests constraints. But then we hit the hard questions, the ones that keep researchers awake, the ones that make believers feel vindicated, the ones skeptics sometimes avoid because they're inconvenient. First, the timing paradox. Some reports describe structured experiences, narratives with sequence and detail, during periods when measurable brain activity appears severely compromised. In cardiac arrest, EEG can flatten. Blood flow can drop dramatically. And yet the returned person can describe a coherent episode. There are several ways this could happen without violating physics. The experience could occur during the descent into unconsciousness or during the climb back, when activity exists but isn't being measured well. The memory could be assembled after the fact, stitched together from fragments, like a dream you only realize you had when you wake. EEG is also a limited window. It measures large-scale synchronized activity near the surface, not every whisper of deeper structures. But we should be honest, we do not yet have a precise mapping from subjective time to neural time during medical crises. The measurement gap is real. Second, claims of veridical perception. These are the stories where someone says, "I saw what the doctors did," or "I heard a conversation," or "I noticed an object on a high shelf," while they were supposedly unconscious. Many such cases are explainable. People can hear under anesthesia more than we assume. They can pick up cues during partial consciousness. Staff can inadvertently reveal details later. Memory is suggestible. And yet, if we're auditing honestly, a subset remains debated. Not because it proves anything supernatural, but because it exposes how hard it is to do clean experiments at the edge of death. Hospitals are not designed as consciousness laboratories. A resuscitation is chaos with a purpose. So where does that leave us? Here comes the pivot, the moment the puzzle stops being an argument between "it's real" and "it's not," and becomes a deeper insight about what minds are. The clustering itself is informative. Similar stories do not automatically mean a shared external place. They can also mean a shared internal machine responding to shared constraints. When you press on the same architecture in the same way, you can get the same artifacts. Like how different people, in different countries, will see the same shimmering mirage over hot asphalt. The mirage is not a separate world, it's a signature of how light and perception behave under certain conditions. Near-death motifs may be the mirages of a brain under metabolic stress, not trivial, not meaningless, but informative. They tell us what the mind defaults to when its usual anchors dissolve. They showed the skeleton of consciousness, prediction, social modeling, body ownership, narrative continuity, revealed when the flesh of ordinary perception falls away. Now zoom out. The implication is not, your experiences are fake. The implication is more radical. The brain may not show you reality the way a window shows a landscape. It negotiates a survivable model of reality the way a ship's navigator negotiates a route through storms. And in the final minutes, the negotiation changes. Less input, more inference. You can feel the weight of that. Your daily sense of, I am me, is not a static object sitting in your skull like a jewel in a box. It's an active process, an ongoing agreement among networks about what matters, where you are, and what comes next. If that's true, then dying is not a single moment. It's a cascade of changing models, each with its own internal logic. And here's the all without overclaiming, even if near-death experiences are generated by the brain, they may still reveal deep truths about what consciousness does. Consciousness compresses the world into graspable form. It integrates scattered signals into a single felt scene. It searches for meaning the way lungs search for oxygen. And when continuity is failing, it creates continuity anyway, sometimes by building a doorway, a guide, a review, a boundary, so the story has an ending that feels like an ending. If you've ever sat with someone who is dying, you know how strange time becomes in the room. The air feels different. Conversations quiet down. People start speaking in essentials. It's as if the universe narrows to a few variables: breath, pulse, warmth, presence. So let's return there. The bedside monitor line trembles. A nurse adjusts a drip. Someone wipes a forehead with a cloth that's been wrung out too hard. The hand-holding continues because touch is an ancient language, older than any theory we'll ever write. And inside that skull, inside that private darkness, energy is being negotiated moment by moment, ADP spent, gradients held, predictions updated, models rewritten. And maybe, in some cases, the last act of the brain is not silence. Maybe it is story. Not story as fiction. Story as compression. Story as meaning. Story as the mind's final attempt to keep you whole while the parts are letting go. So here's the respectful question I want to leave you with. If your brain's last act is to tell you a story, what kind of story is it designed to tell? And why those symbols, those tunnels, those lights, those presences, again and again? In a moment you'll see an end screen with a next investigation. Click that, not because it's related content, but because the best way to honor a mystery is to keep following it while it's still warm. And if you want more audits like this, where we treat human experiences as data without stripping them of dignity, subscribe. That tells the algorithm to send you the next frontier the moment it's ready. One question for you, and I'll read what you write. If you had to guess, which near-death motif feels most convincing to you, the tunnel, the peace, the out-of-body view, or the life review? And what do you think it says about what you fear or what you hope?